An altimeter or an altitude meter is an instrument used to measure the altitude of an object above a fixed level. The measurement of altitude is called altimetry, which is related to the term bathymetry, the measurement of depth underwater, used in ground effect vehicle. After extensive research and experimentation, it has been shown that phase radio altimeters are most suitable for ground effect vehicles, as compared to laser, isotropic or ultrasonic altimeters. Sonic altimeter. In 1931, the U.S. Army Air Corps and General Electric tested a sonic altimeter for aircraft, which was considered more reliable and accurate than one that relied on air pressure when heavy fog or rain was present. The new altimeter used a series of high-pitched sounds like those made by a bat to measure the distance from the aircraft to the surface, which on return to the aircraft was converted to feet shown on a gauge inside the aircraft cockpit. Radar altimeter. A radar altimeter measures altitude more directly, using the time taken for a radio signal to reflect from the surface back to the aircraft. Alternatively, frequency-modulated continuous wave radar can be used. The greater the frequency shift, the further the distance traveled. This method can achieve much better accuracy than the pulsed radar for the same outlay, and radar altimeters that use frequency modulation are industry standard. The radar altimeter is used to measure height above ground level during landing in commercial and military aircraft. Radar altimeters are also a component of terrain avoidance warning systems, warning the pilot if the aircraft is flying too low, or if there is rising terrain ahead. Radar altimeter technology is also used in terrain following radar, allowing fighter aircraft to fly at very low altitude. Global Positioning System. Global Positioning System receivers can also determine altitude by trilateration with 4 or more satellites. In aircraft, altitude determined using autonomous GPS is not reliable enough to supersede the pressure altimeter without using some method of augmentation. In hiking and climbing, it is not uncommon to find that the altitude measured by GPS is off by as much as 400 feet depending on satellite orientation. Other modes of transport. The altimeter is an instrument optional in off-road vehicles to aid in navigation. Some high-performance luxury cars that were never intended to leave paved roads, such as the Duesenberg in the 1930s, have also been equipped with altimeters. Hikers and mountaineers use handheld or wrist-mounted barometric altimeters, as do skydivers. Diesel submarines have barometers installed on them to monitor vacuum being pulled in the event that the snorkel closes while the diesels are running and, as a consequence, sucking the air out of the boat. Satellites such as CSAT and TOPEX, Poseidon use advanced dual-band radar altimeters to measure height from a spacecraft. That measurement, coupled with orbital elements, enables determination of the terrain. The 2 different wavelengths of radio waves used permit the altimeter to automatically correct for varying delays in the ionosphere. Space-borne radar altimeters have proven to be superb tools for mapping ocean surface topography, the hills and valleys of the sea surface. These instruments send a microwave pulse to the ocean's surface and record the time it takes to return. A microwave radiometer corrects any delay that may be caused by water vapor in the atmosphere. Other corrections are also required to account for the influence of electrons in the ionosphere in the dry air mass of the atmosphere. Combining these data with the precise location of the spacecraft makes it possible to determine sea surface height to within a few centimeters. The strength and shape of the returning signal also provides information on wind speed and the height of ocean waves. These data are used in ocean models to calculate the speed and direction of ocean currents and the amount and location of heat stored in the ocean, which in turn reveals global climate variations.